Okay, let's talk about numbers. I mean, we use them every single day, right? But do we ever really think about them? Well, it turns out there's this whole universe of numbers out there. Some are super familiar, and some are, well, they're pretty mysterious. So let's dive in and start exploring.
Seriously, think about it for a second. You've been using numbers your whole life for counting, for measuring, for, well, everything. But have you ever stopped to wonder if they're all kind of the same? Are they all created equal? Or are there totally different types of numbers just hiding out there right under our noses?
So that's what we're going to do today. Think of it like this. We're going to explore this huge universe of numbers. We'll start in a place that feels familiar and safe, with the numbers we already get. And then we're going to blast off into the strange, vast cosmos of math. All right, first stop, our home base. This is the world of what we call rational numbers. And honestly, it's a world that just makes sense. Everything here is orderly, it's predictable, it's nice and tidy. So what's the entry requirement for this Makes Sense Club? It's actually super simple. A number is rational if and only if you can write it as a fraction. One integer on top, another integer on the bottom. That's it. That's the whole rule.
So, who gets to be in this club? Well, you've got all the usual suspects, right? Integers like 1, 2, -3, they're all in. Simple fractions? Of course. But decimals? Now, this is where it gets a little interesting. Only two kinds of decimals are allowed in. First, the ones that just end, like 0.25. And second, the ones that go on forever, but, and this is a big but, they have to repeat in a nice predictable pattern. And this is where you can really see the difference, right? On the left, you've got our nice, orderly, rational numbers. I mean, 369, that's just 369 over 1. No big deal. But on the right, whoa, these are the mysterious ones. Numbers like the square root of 10 or the famous pi, their decimals just go on and on and on forever with no pattern at all. It's impossible, literally impossible, to write them as a simple fraction.
Okay, hold on a second. I know what you're thinking. You just said some decimals that go on forever are rational. And you're right. So what's the deal? Well, there's a really important catch here. Let's take a closer look. All right, look at this decimal right here. At first glance, it just looks like a random string of numbers, right? But is it really random? Let's see what happens if we keep it going. And there it is. See that? A pattern starts to show up. That 819 sequence, it's just repeating itself over and over and over again forever. And because we can predict what's coming next, it gets to join the rational club. It looks like chaos, but it's actually got this really cool hidden order to it. So you can imagine mathematicians don't want to write 819 forever. So what do? They came up with this really clever shorthand. They just put a little dot over the first and last number of the repeating part. It's basically their way of saying, hey, see this 819 block? Yeah, that's the part that just keeps on going. It's a super elegant way to bottle up an infinite idea. Okay, so we've got a pretty good handle on our home planet of rational numbers, right? Now it's time to zoom way out and see the bigger picture, the whole number line. We're heading out to the real frontier. And this is where we meet the real numbers. Just think of the real numbers as, well, the whole shebang. It's the big umbrella category. It includes that nice, neat ox of rational numbers we just talked about, but it also includes all that wild, unpredictable stuff, all those irrational numbers like pi that just go on forever without a pattern. And this is the really cool part. Together, these two types of numbers, the rational and the irrational, they make up every single point on the number line. I mean, every point. If you could zoom in forever and point to any spot, no matter how tiny, you would be pointing at a real number. There are no gaps. It's a complete, continuous line. Okay, that's a cool idea, but it brings up a really practical question, doesn't it? If these irrational numbers have decimals that go on forever, how in the world do we actually use them? I mean, you can't type an infinite number of digits into a spreadsheet to build a bridge or something. Well, the answer lies in a tool that we all have. It's the thing that tames these infinite beasts for us. I'm talking about the calculator. It's like a bridge that connects the super abstract world of endless numbers to the practical world where we actually need to get stuff done. Let's do a quick example, something easy, like the square root of 9. You know the drill, you press the square root button, you press 9, and you hit enter. And boom, you get a nice, clean 3. A perfectly rational answer. Easy peasy. But the calculator's real magic shows up when we give it something, well, something like this. Look at that monster of an equation. You've got powers, division, parentheses inside of parentheses. Trying to solve this by hand? Oh man, that would be a nightmare. You'd be making mistakes all over the place. But for your calculator, it's no big deal. It just chugs along, follows the order of operations perfectly, and spits out one single precise answer. And there it is, -4.395. A nice decimal that ends, which means, yep, you got it. It's one of our friendly, well-behaved rational numbers.
All right, so we've covered a lot of ground here, from the super simple numbers to the really complex ones. So let's just boil it all down to the most important takeaways from our little journey.
Okay, so if you walk away with just two key ideas, make it these. First, rational numbers. These are the neat ones. You can always write them as a simple fraction. And second, real numbers. That's the whole universe. It's every single rational number plus every single irrational number. It's the entire, complete number line.
And that leads us to one last, really fun, kind of mind-bending question. If mathematicians specifically called this whole group the real numbers, well, does that mean there might be some unreal ones out there too? Something to chew on. Thanks for joining me on this one.